Hey everyone, welcome to the last video here for the bell ringer. This last question, we're trying to figure out when the position and times are the same. So the way we start this problem is we pretty much just set both sides of both right sides of the equation equal to one another. So I'm just going to put an equal sign in the middle, and we're going to take each of those values. I'm just going to copy and paste. And then we're going to put one of them on each side of the equation. So I'm going to put my 1.4 meters a second times time. Take away 2 meters on one side. And then the other expression is going to go on the other side. So we're just setting those equal. Okay. And then we just got to figure out where the like terms are. So on the left side here, this first term has a t, and so does the second one. So those are like terms. Since they're on opposite sides of the equal sign, I'm going to use inverse operations to get them on the same side. So I'm going to subtract 1.4 meters a second times time from both sides minus 1.4 meters a second times time. All right, and that gives us, if we work in columns, it cancels out on the right. So negative 3 minus 1.4 would be a negative 4.4 meters per second times time. Oh, that got a little tight, sorry. Plus 5 meters. We're just going to set that equal to the negative 2 meters on the other side. All right, now on this level, the 5 meters and the 2 meters are like terms because they don't have a variable. These are considered constants. So I'm going to get the variables on, or excuse me, get the constants on the right side. So that way only the variable, like this one with the t, that's our variable. We want to get that one by itself. So we're left with negative 4.4 meters a second times time equals negative 7 meters. So like if we were to write this whole equation down without units, it would have started with negative 3t plus 5 equals 1.4 t minus 2. And we would have subtracted 1.4 on both sides, or 1.4 t. All right, and if you notice, that's pretty much the same thing we have. So we ended up with a negative 4.4 t plus 5 equals negative 2. And see, now we subtracted 5. So this would be like a negative 4.4 t equals negative 7. So we would just divide both sides by negative 4.4. And that's what we're going to do over here. We just include the unit, meters per second. So negative 4.4 meters per second. Okay, so if we divide that out, 7 divided by 4.4 is about 1.59. So that means our time is 1.59 seconds. So I'm going to put that right here. And then to figure out position, we're just going to come up to the original equation. And any place I see time, I can substitute in 1.59 seconds. So that's going to get multiplied in this problem by 1.4 meters a second And so notice the second unit cancels out. So then we're going to subtract 2. Subtract 2 meters. So we'll take 1.4 times 1.59. So 1.4 times 1.59. And then take away 2. And that is 0.226. So I'm just going to round that to 0.23 meters.